Efficient arrays of numeric values. This module defines an object type which can compactly represent an array of basic values, characters, integers, floating point numbers. Arrays are sequence types and behaves very much like lists, except that the type of objects stored in them is constrained. The type is specified at object creation by using a type code, which is a single character. The following type codes are defined: B signed character integer 1, capital B unsigned character U, W char underscore T, Unicode character 2 bytes, H signed short integer 2 bytes, capital H unsigned short integer 2 bytes, I signed integer 2 bytes, capital I unsigned integer 2 bytes, L signed long 4 bytes, L unsigned log 4 bytes, Q code signed long 8 byte, Q capital unsigned long 8 byte, F float 4 byte, D double 8 byte. Notes: it can be 16 bits or 32 bits depending on the platform. The actual representation of values is determined by the machine architecture, strictly speaking by the C implementation. The actual size can be accessed through the array.itemSize attribute. The module defines the following item: arrays.typecodes, a string with all available type codes. The module defines the following type: class array typecode, initializer, a new array whose items are restricted by typecode and initialized from the optional initializer value, which must be a list, a bytes like object, or iterable over elements of the appropriate type. If given a list or a string, the initializer is passed to the new arrays from list, from bytes, or from union code method. See below to add initial items to the array. Otherwise, the iterable initializer is passed to the extend method. Array objects support the ordinary sequence operations of indexing, slicing, concatenation, and multiplication. When using slice assignment, the assigned value must be an array object with the same type code. In all other cases, type error is raised. Array objects also implement the buffer interface and may be used wherever the bytes like objects are supported. Raises an auditing event array.new with arguments typecode, initializer, typecode, the typecode character used to create the array, item size, the length in bytes of one array item in the internal representation, append x, append a new item with value x to the end of the array. Buffer underscore info, return a tuple address, length, giving the current memory address and the length in elements of the buffer used to hold array's contents. The size of the memory buffer in bytes can be computed as array.bufferinfo 1 into array.itemSize. This is occasionally useful when working with low-level and inherently unsafe I/O interfaces that require memory addresses, such as certain IOCTL operations. The return numbers are valid as long as the array exists and no length changing operations are applied to it. Note: when using array objects from code written in C or C++, the only way to effectively make use of this information, it makes more sense to use the buffer interface supported by array objects. This method is maintained for backward compatibility and should be avoided in new code. The buffer interface is documented in buffer protocol. Byte swap. Byte swap all items of the array. This is only supported for values which are 1, 2, 4 or 8 bytes in size. For other types of values, runtime error is raised. It is useful when reading data from a file written on a machine with a different byte order. Count x. Return the number of occurrences of x in array. Extend iterable. Append items from iterable to the end of the array. If iterable is another array, it must have exactly the same type code. If not, type error will be raised. If iterable is not an array, it must be iterable and its elements must be the right type to be appended to the array from bytes. Appends items from the string. Interpreting the string as an array of machine values as if it had been read from a file using the from file method. From file fn, read n items as machine values from the file object f and append them to the end of the array. If less than n items are available, end of file error is raised, but the items that were available are still inserted into the array. From list append items from the list. This is equivalent to for x in list a dot append x, except that if there is a type error, the array is unchanged. From Unicode S extends this array with data from the given Unicode string. The array must be a type U array, otherwise a value error is raised. Use array.from bytes Unicode string.encode enc to append a Unicode data to an array of some other type. Index x start to stop. Return the smallest I such that I is the index of the first occurrence of x in array. The optional arguments start and stop can be specified to search for x within a subsection of the array. Raise value error if x is not found. Insert ix. Insert a new item with value x in the array before the position I. Negative values are treated as being relative to the end of the array. Pop I removes the item with the index I from the array and returns it. The optional are defaults to -1 so that by default the last item is removed and returned. Remove x. Remove the first occurrence of x from the array. Reverse the order of the items in the array. 2 bytes. Convert the item to an array of machine values and return the bytes representation. The same sequence of bytes that would be returned to a file by the toFile method. ToFile f. Write all items as machine values to the file object f. ToList. Convert the array to an ordinary list with the same items. ToUnicode. Convert the array to a Unicode string. The array must be a type UArray, otherwise value error is read. Use array.2bytes.decode enc to obtain a Unicode string from an array of some other type. When an array object is printed or converted to a string, it is represented as array typecode initializer. The initializer is omitted if the array is empty. Otherwise, it is a string if the typecode is U. Otherwise, it is a list of numbers. The string is guaranteed to be array to be converted back to an array with the same type and the value using eval, so long as the array class has been imported using from array import array examples. See also array L, array U, hello \u 2641, array L 12345, array D 1.0. See also module struct, packaging and unpackaging of heterogeneous binary data. Module xdr-lib, packaging and unpacking of external data representation. XDR data as used in some procedures call system. NumPy. The NumPy package defines another array type. Thanks.